Hello everybody, and welcome to the continuation of the preliminary example on page 23. So in the previous video, we actually calculated the first two numbers in this table, drew in some tangent lines and figured out the slopes. And I asked you to fill in the rest of the table, so you can compare your numbers to the numbers that I got here. Now, if your numbers don't agree exactly with mine, that's okay, because drawing a tangent line is a very difficult thing to do exactly. Hopefully, though, we agree at least on the sign of the numbers. If I have a negative number, you have a negative number, and if I have a positive number, you have a positive number. Okay, other than that, though, there's going to be some room for error here. All right, well, what we're about to do then is to draw a graph of what's known as the derivative function. Okay, and just so that our graph over to the right here doesn't get too busy, I'm going to go ahead and erase the tangent lines that have been drawn in. Okay, so let's get rid of those. Okay, and what we're going to do now is to take this table of values that we have, okay, and the numbers that we got in this column are slopes, but we're going to reinterpret those numbers as being y-coordinates. Okay, so for example, negative 3, 2, think of that as just an x and a y coordinate. We can plot that point, negative 3, 2, and it would be up here. Okay, and then we move on to the next one, negative 2 and 1/3. That's about maybe there. Negative 2 to the left and 1/3 up. And then negative 1 and negative 2/3, that's about here. And we just keep going. Then 0, negative 1, 1, negative 2/3, 2 and 1/3, that's about there, and finally 3 and 2. Okay. And let's go ahead and just kind of draw a smooth curve through those points, just doing the best that we can here. Okay, so something like this, just very roughly. Okay, notice that that graph has sort of the shape of a parabola, and what we have just drawn is called the derivative function of f. Okay, it's a way of kind of visually looking at all of the slopes on the graph of f at once. Okay, now there's a lot of interesting correspondences between the function and its derivative graph. Okay, we're going to mention a couple here, but we're going to notice all kinds of additional correspondences as we go forward in the semester here. And I want to start you just with the most basic connection between these two graphs. So keep in mind the following, that the slope of f, the slope of the tangent line to f, equals y values of the derivative. That's the correspondence that allowed us to draw the red derivative graph that we just drew. Okay, so with that kind of in mind, let's make a couple of observations here. Okay, and like I say, this is going to be a short list. We could add a lot of things to this, but we'll just make a few basic ones here. Okay, the first thing I'd like you to notice is the places where the derivative graph crosses the x-axis. Do you see any points like that? Okay, I see a couple of places. Here's one place where the derivative crosses the x-axis, and here's another one. What's special about the function at those 2 points? Okay, well, if we go up and find the point on the original function, notice that the slope of the tangent line is 0. It's horizontal there. Okay, and the same is true at the other place. Okay, so that 0 slope matches the y-coordinate of the derivative at that point. Okay, so we could complete this statement down here in 1 by saying f prime crosses the x-axis where f of x has a horizontal tangent line. Okay. And I want to add 2 things to this list. Okay, so next thing I'd like to pay attention to is where is the graph of the derivative greater than 0? And graphically, that would mean above the x-axis. Okay, well, one place where the derivative graph is above the x-axis would be this stretch from here to here. I'm going to do this in green. from there to there. Okay, and what's going on with the original function on that stretch? If we highlight that same stretch of f, that would be from here to here. Notice that we're going up left to right. So where our function is increasing, the derivative is above the x-axis. Notice that there's another part of our derivative graph over here to the right that's above the x-axis. And we could say the same thing about the corresponding stretch of f. It's going up as we go left to right. So going back down to point 2 here, f prime of x is greater than 0, where f of x is increasing. Okay, increasing is just a way of expressing the fact that it goes up left to right. Okay, and we could make a similar statement about where the derivative graph is below the x-axis. Okay, that would be if we highlight that on our graph, this stretch right here is below the x-axis, and notice that the function, that same stretch of the function is going down left to right. Okay, so we can say where the original function is decreasing. Okay, and again, we could add a bunch of other things to this list and make a really long list of observations. You may have even noticed some things that we didn't write down. Okay, but very basically, that's just kind of a start of some connections, and we'll notice some more as we continue with this section.